Good morning or good afternoon, depending when you're watching at Year 8s. Welcome to our little remote learning lesson on hot rocks or volcanic rocks. This goes with section 9.3. Volcanic rocks, hot rocks, because we have an idea, don't we, that lava is extremely hot, and it is. By the end of the lesson, we hope we can understand how igneous rocks are formed, but using their characteristics, and to learn about the different types of igneous rocks. So igneous rocks is another name for volcanic rocks. Okay, igneous. Now, this picture shows us a whole range of different types of igneous rocks. We've got to start using that word igneous instead of volcanic. So I need to move this little picture over so you can see the heading. Sorry about that. Now, there's two places that these igneous rocks can form. One is intrusive. So not all volcanoes actually explode out of the ground and make it to the air or to underneath the ocean hitting water or whatever, okay? Or maybe even mountaintops and hitting ice. So there's lots of different rates of cooling. So some igneous rocks actually cool below the ground and they're called intrusive. Now, do you remember how I talked about in minerals how the length of time determines whether crystals are made or not? So it's the same thing here with intrusive rocks, that they cool very slowly because they haven't even made it above the ground yet. So they stay warm for a very long time. And so they have minerals that have formed crystals in them. Remember, rocks are made of minerals. So if you have a look at this picture, it's really clear that a couple of these are intrusive rocks. There are a couple that are hard to work out, but there are a couple that are clearly intrusive rocks that have crystals in them that you can see. So this one here would be some type of granite, and you can see there are dark minerals and there are light coloured minerals in there, and you can actually see that there are different types of minerals. They're not all mushed up together. It's cooled slowly, and you can see that that's made of crystals. There's another one that looks a bit like that, but it's pinker, which is down here. This is definitely a pink granite, and again you can see that that's quite a big crystal there, and then some other chunks of different kinds of minerals like feldspar and mica and orthoclades are some of the names of some of the minerals you might have done in the first activity, and they've cooled slowly. Right? A couple of these have cooled really quickly. In fact, this one in the middle here, that's a pumice, and that's got air holes in it. And that one has just blown straight out of the top of a volcano. It's also been full of gas. You can tell this was full of gas because it's got these air holes in it. And you can also tell it cooled really quickly because there's no crystals. You can't see any, all right? And all the others are variations, okay, of that. To be honest, I don't know every single one. I do know this is a basalt, which would have been a lava flowing, all right? This is another kind of intrusive rock that would have cooled slowly. And I have to tell you the honest truth, I'm not exactly sure what these ones are. So if anyone knows, there's a challenge for some of you advanced students, you can tell me what those rocks are. That'd be awesome. So on the next, you can obviously read all of this yourself. This rock here is undoubtedly one of my favourites, and it's called obsidian. Now, it is very glassy, and this is a rock that has cooled super fast, right? There's not a single crystal you can see. It looks like one sheer sort of mass of the same thing. And it has quite possibly even come out of a volcano and hit something really cold, like ice or really cold water maybe. But it has cooled super fast, however that's happened, and it gives you this glassy idea. So it's come from a volcano and cooled quickly. We can tell the different types of rocks. We can see how hard they are, what minerals they're made of, and if you could actually cut into them, geologists do this and they make really super thin slices and put them under the microscope, and you can see how the crystals actually grow and interlock together. So that is a particularly fast cooling extrusive rock. Anything that happens as it comes out to the Earth's surface is extrusive. Okay, there's another really cool example of some lava flowing, and that kind of rock is called pillow lava because it sort of makes this pillowy shape, and commonly if it's cooled like this it would form a rock called basalt. turns into a solid very quickly, and it does, it says here, has very small crystals. Not as small as obsidian, but still pretty small. You've got these ones, like the pumice, that have got lots and lots of air in them, and if you were able to hold these, they'd be very light. We can use pumice, in fact, some of you might have some at home in the bathroom, to rub off dead skin from your feet or wherever, and it's quite hard, but it's very, very light. And so these have come usually out from the top of a volcano, super fast, but also full of hot gas. Scoria is probably a little heavier than pumice, and there's heaps of different types of scoria. You might even have some scoria or types of it in your garden because it's often used as pebbles and things like that. Now, we talked about obsidian in the slide earlier. I just love it. It's just so gorgeous. And we do have, when you finally get back to school, hopefully your teacher will show you some of these because they are really cool. And basalt, this looks like it's down at the beach, doesn't it? Okay, so you can see some of this basalt has some air bubbles in it, but not all does. Bluestone, you may have heard, you can build with that. That's basalt. And also the tar on the road. Most of those sort of pebbles or the gravel that you see made up on roadsides and stuff, generally, not always, but generally is a basalt. And that is an extrusive rock, so it's come out of the top and it's cooled fairly quickly, but not as quick as obsidian. Now, what about these rocks that form underground? Sorry, I'm moving this thing around, that's really funny. Rocks that form underground, however, cool really, really, really slowly. So you can see on this diagram, this is really good. Boom, out the top here, you've got your basalts sort of flowing out, and your scoria and your pumice shooting out the top, or maybe if this was covered in snow or ice, you might get obsidian forming here as the lava shoots out and hits the surface, okay? But you can see down here, this is the type of rock that doesn't make it to the surface. So it stays hot for a really long time and very slowly cools. It's like cooking a cake in the oven, cheesecake, best thing ever. You cook it and you turn the oven off and you leave the door shut for a couple of hours so it cools really slowly, right? Best cheesecake, tell your parents. But this is the same kind of thing, okay? This is cooled super slow, and what you get are lots of crystals in the rock when that happens. So I'll just go to this because this is a really good example. So you can see all of the different crystals that have formed because it has cooled really slowly, and your granites are very common rock made of different minerals, and it's often used bench tops in kitchens. Just going back to here, this is just how you form something called a batholith. Oh, I can't even say it. Batholith. And the Kimberleys, like sort of the Ayers Rock and Kimberleys and all that sort of thing, sort of formed that way. So that's just where you have an really hard, intrusive rock under the ground, and then over time, all of the other stuff gets weathered away, and you end up seeing what was under the ground once upon a time. So that's quite a cool thing. All right, now, sorry, there's a blank page, but what you're going to do, I'm actually going to pop over to Simon. Just hang on a second. I will pop onto a Simon page to show you what to do. Cool. So you can see that this learning activity with hot rocks is a bit different. And oh, hang on, it says it's not available. Sorry, go to resources. My bad. And you can see the PowerPoint that I've just been going through and a little video here on how fast and cooling makes a difference. And your job is to watch this video, okay, some cool music that goes with it too, and open up this and to the best of your ability, answer the questions in this prac sheet, because you need this to be able to answer that. It's not going to be a perfect fit, but it's going to be pretty good. Do the best you can and then upload it onto Simon, and I'll see you soon for the next one.